In this section of the course, we're going to be learning about consumer choice. And to begin to think about consumer choice, we're going to start to think about modeling consumer preferences. That means what you like. If I say I've got an apple or a banana, which one you choose tells me something about what makes you happiest. That's what we're trying to model as we develop the concept of a utility function. So Cardinal utility refers to the actual number value of happiness, which really is quite meaningless to us because what we're interested in is thinking a little bit more about what the trade-offs look like. How do you decide whether or not to choose the apple or the banana? And not so much what number of happiness it brings you. So we're interested here in ordinal utility, the comparison of happiness between apples and bananas, and not necessarily cardinal utility or the value of that happiness. To start to think about preference ordering, so that would be like saying, I like apples better than bananas, but I like bananas better than carrots, right? We need those preference orderings to be rational in the sense that we can predict how you would behave in any number of situations based on your preferences. And in order to have a rational preference ordering, we need those preferences to meet these three criteria. Completeness, we need to be able to rank any possible bundle to evaluate where it falls within the preference ordering. We need preferences to be transitory. In other words, if you prefer apples to bananas and bananas to carrots, then necessarily you prefer apples to carrots. And we need them to have monotonicity, which just means that more is better, right? Like if you like apples and you have one, and I give you a second one, you will be happier. So it means that holding everything else constant, having more of a product that makes you happy will in fact make you happier, or it will at least never make you sadder. Okay, so we're going to develop some mathematical functions to help us think about what preference orderings might look like for a consumer, and then the consequence of that for consumer choice, for consumer behavior. But to start, we want to think just very simply about how to describe utility functions. So before we get into the more complicated utility forms, we're going to start with some really simple functions that just have one good, and we'll use that to learn the tools with which we can evaluate utility. A utility function is just an equation that transforms consumption goods into utility, this measure of happiness for our person, our consumer. And like I said, we're going to start with a really simple example here. Square root of f, say f is the only thing you consume, so let's make it food, right? And your utility is equal to the square root of the quantity of food that you consume. So what does this utility function look like? Well, we can plug in just a few simple values for f, right? I want to make it easy to take the square root here. And then my utility is just the square root of that. So if I put that on my graph, I've got what ends up here being a concave function. And that's not a coincidence, because in order to be what we would describe as well-behaved, a utility function should be concave. So let's talk a little bit about what that means and why. Looking at this picture, I see that as I consume more food, I get happier, right? More utility means more happiness. More food gives me more utility, gives me more happiness. That's the kind of monotonicity requirement here. We also notice that the utility function is increasing at a decreasing rate, right? So at first, eating 1 unit of food gives me an additional utility of 1 unit. But if I come out here after I've eaten a lot of food, right, my utility function doesn't go up very much for that additional unit of food. This is the law of diminishing marginal utility, and it should be true for all kind of well-behaved utility functions, but just should be true in general for most goods in life, right? The more you consume of something, the less happiness each additional unit brings you. That first slice of pizza is going to taste really good. The 7th slice of pizza, probably not so much. At some point, you don't want it anymore because you're full, you're satiated. And that's not just true for food, it's true for really any good that you can think of. And so we want our utility function to follow these 2 basic criteria. And mathematically, that means that the utility function should have a positive first derivative and a negative second derivative, right? It's concave. Remember, we're in a cave. And that's what a good utility function should look like.